Hello and welcome to the June 2023 Longevity Review, presented to you by the Canadian Longevity Association, a federally incorporated nonprofit whose mission is to help accelerate the introduction of effective longevity treatments and to ensure their free availability to all Canadians under the healthcare system. My name is Chris Linnell, and I'm the founder and president of the association. We are a volunteer-run organization and are always looking for more help. So if you'd like to assist us in achieving our goal, then please get in touch via the links below this video. In addition, you can also find a link to the newsletter being discussed in this video. This month, we will look at the potential health and longevity benefits of taurine, a few different senolytic papers, including the first longer-term study in primates, as well as how AI might help us find more senolytic drugs. In addition, we'll also look at how exosomes from induced pluripotent stem cells might be beneficial. But first, some brief CLA news. As you can see at the top of the page, our logo has been updated to include the all-important maple leaf. This came about due to the initiative of one of our volunteers, Miles, who was able to enlist the services of a professional graphics designer, Dwight Alexander, to help us out in updating that logo. So firstly, thank you very much to Miles and Dwight Alexander for that. In addition, the other big news from June was the fact that after completing our legal obligations in May, we were finally able to open up a bank account, which we did with Alterna Savings, who are a credit union here in Ontario. We're now currently working on getting our donations page all set up, and hopefully I'll be able to tell you about that next month. Moving on to the meat of this review, the first study that we will look at involves the amino acid taurine, perhaps best known for its use in energy drinks such as Red Bull. Now, this study caused quite a bit of stir and actually made the front page of the BBC, which is a rarity in the longevity field. And the reason why it did so was the fact that it was shown to improve the lifespan of mice by 10 or 12%. However, the reason I found this study very impressive was not just the fact that it improved the lifespan of mice by 10 or 12%, but was because of the range of species which it covered. So instead of just focusing on yeast or worms or mice or indeed monkeys, this study covered all of those. So they looked at the effects of taurine in yeast, in worms, C. elegans, in mice, and indeed in monkeys, and also looked indirectly at its effects in humans. Now, I was going to show you the full text, but it's now disappeared behind a paywall, so we will take a look at the lifespan.io analysis of this paper. And well, there you can see the chemical symbol for taurine. Get rid of this ad. As you can see here in these charts, taurine decreases with age in mice, monkeys, and also humans. So I guess the question is, if you boost it in these animals, would that lead to a benefit? Now, when they gave it to yeast, there wasn't much of an effect. However, when they gave it to worms, it resulted in up to 23% improvement in lifespan. When given to mice, as you can see by the next chart, it led to a 10 to 12% increase in lifespan, 10% in males, 12% in females, as you can see here. Importantly, the graph sort of shifted to the right, which is important. And perhaps more importantly, it also increased health span. As you can see here, in female mice, it improved age-related weight gain or reduced age-related weight gain. It increased bone mass and quality as well as the animal's fitness. It reduced depression-like behaviors such as disinterest in exploration. And the taurine mice fed mice were healthier metabolically with improved insulin sensitivity. In mice, in male mice, it did not affect the body mass, but improved body composition and reduced adiposity, which is basically the fat levels, and probably also increased energy expenditure. Taurine-treated males showed greater muscle strength, neuromuscular coordination, bone density, glucose tolerance, and memory, as well as reduced anxiety. So a broad range of beneficial effects in mice. In monkeys, taurine produced a reduced age-related body weight gain, a lower fat percentage, lower fasting glucose levels, and reduced liver damage markers. Now, one of the differences between the mouse and monkey studies was that whereas both of them were given to mice and the monkeys when they were middle age, where the mice took taurine daily for the remainder of their lives, whereas the monkey study was only for 6 months. So they didn't find out whether or not it could also extend their lifespan. But considering how long their lifespans is, we didn't want to wait another 10, 15 years or so. And yeah, the monkeys were 15 years old when they were started on taurine. I should also mention that the human equivalent was between 3 and 6 grams of taurine a day. Now, it's moving to humans because the researchers also analyzed a data set of 12,000 people. They found that higher taurine levels were associated with lower BMI, glucose levels, C-reactive protein, a marker of inflammation, and a lower prevalence of diabetes. And they also determined that taurine levels go up following a bout of exercise. Now, before you rush out and buy some taurine supplements for yourself, because taurine is available as a supplement, a word of caution should be mentioned. Peter Attia, who many of you might know, and who, by the way, is also Canadian, in a blog post, which can be found in the Lifespan article, questions whether or not taurine actually could be that beneficial in humans, because fundamentally the metabolism is different in humans compared to mice and monkeys, or at least the rhesus monkeys used in the study, primarily because the mice and the monkeys are more herbivores and just produce taurine themselves, whereas being omnivores, we get a lot of taurine through the consumption of meat, besides producing it in our own bodies. And he sort of likens it to the fact that any extra taurine we take in might just be excreted. But fundamentally, we will only know once human studies take place, and that's why the final paragraph of this article is crucial, because the lead author, Vijay Yadav, associate professor of genetics and development at Columbia University in New York City, says that the metabolism of taurine indeed varies from species to species. This is very much a reason we are putting together a randomized clinical trial to investigate whether the effects that is seen in animals is applicable to humans. So yeah, probably best to hold on to your horses. But considering that taurine is safe to take, the choice is yours, because it will probably be several years before we find out more answers regarding taurine. But anyway, regardless, it's always exciting to see a new molecule shown to potentially improve both health and lifespan. Moving on to the first of our senolytic studies, this also involved middle-aged monkeys given a treatment for 6 months. This time, our old friends dasatinib and quercetin, which are the most studied of senolytic drugs. Now, just a little bit of a recap. So, senolytic drugs remove senescent cells from our bodies. Now, senescent cells are rogue cells which accumulate with age, and they release all sorts of inflammatory markers, which cause all sorts of dysfunction in our bodies, and removing them seems to produce great benefit, at least in mice. Now, human clinical trials using dasatinib and quercetin have already taken place and are taking place, but the ones that have been released so far are only of short duration. And this study was quite interesting because it was involving obviously primates, which are closer to us than mice, and it was over 6 months, over a 6-month period. So much closer to what could be expected in humans. And as I said, is primarily a safety study. Anyway, let's take a look at it. Once again, unfortunately, the study was behind a paywall, so we are going to look at the lifespan.io write-up of it. And once it loads, here it goes. So firstly, I believe the monkeys were given a 2 days, basically 2 days a month treatment of D and Q, as we like to shorten the name to. So twice a month for 6 months, followed by sort of 6 weeks of 10% calorie restriction, which was both done in the monkeys getting the senolytic drugs as well as the control monkeys. Now, this was a very small study, only 16 monkeys in total, but still it provided us with some interesting results. Now, firstly, and perhaps most importantly, the study showed that D and Q reduced the senescent cell burden in the monkeys, and as can be seen by the expression of P16 and the P21 genes, which are markers of senescence. You can see there, the white bars are control, the gray bars are the treated animals, and after 3 months, in this case, there was a substantial reduction in senescent cells. Now, beyond just looking at whether or not the drugs could actually remove senescent cells, they also wanted to see if they could provide any benefit. And lo and behold, they did seem to provide some benefit. Now, they showed an anti-inflammatory effect. And there was a mild synergy between the senolytic drugs and calorific restriction, because the inflammation was further reduced. But also another beneficial aspect of D and Q was that it led to a significant improvement in markers of intestinal barrier integrity. So yeah, basically, it's our intestinal barrier prevents microbes from going from our gut into our bloodstream, and that declines with age. So if the integrity can be improved, that is obviously beneficial. Secondly, as well, kidney function seemed to benefit from senolytic treatment. So the blood urea nitrogen, or the BUN, a common marker of kidney health, was significantly improved. Those calorific restriction did not add any benefits. Now, a few of the aspects did not necessarily improve. As I said, on the metabolic front, there were no significant benefits. However, combining the senolytics and mild calorific restriction improved there was an interesting synergistic effect between the two treatments in improving hemoglobin A1C, HbA1c, an important metric of average glucose. So it's a marker of diabetes. So the reduction there is good. Now, also one thing to mention is the fact that in this trial, they also utilized or had diabetic monkeys. So 3 monkeys in the treated group and 3 monkeys in the control group. And for the diabetic monkeys given D and Q, their senescent markers of the senescent cells were reduced even further than the monkeys who did not have diabetes. Now, the most important thing from the study, however, was the fact that it didn't produce any adverse effects. The monkeys tolerated the senolytic drugs quite well, and so they had a good safety profile, which, and as the authors themselves state, it provides good information for the construction of long-term human trials, and gives researchers something to work on. Okay, moving on to the next couple senolytic studies, also involving dasatinib and quercetin. The first one actually was in not in monkeys, not in mice. Actually, was in killifish, which are well, they're fish, but they're actually the shortest lived vertebrates. So they're increasingly being used in longevity studies because results can be achieved in a shorter time frame. And in this study, they looked at how dasatinib and quercetin could affect adult neurogenesis in killifish, because supposedly killifish have a good regenerative capacity for their brains, but that declines with age. And when they were given D and Q, that ability to form new neurons returned, not quite to youthful levels, but still substantially. Let's just take a look at some of the results here. So, well, firstly, so that's, hold on, next thing, here we go. Firstly, D and Q removed the senescent cells from the brains of these fish, as you can see there from these graphs. The gray bar is the control fish, and the blue bars are the treated fish. As you can see, there was a reduction in the senescent cell burden, and also all these various markers like P21, which was got mentioned before, all showed a reduction in yeah, just they showed a reduction. Now, also, short treatment with DNQ improved the neurogeneration of the aged telecephalon. It's part of the brain, basically, after stab wound injury. Ouch. Hopefully the fish weren't hurt too much by that. But anyway, you can see here, so adult progenitor cells, which basically produce new neurons, increased in the treated fish. You can see here, once again, the gray bar being control, blue bars being the treated fish. And let's see, there was a substantial improvement there. In addition, so that was adult, sorry, the cells which produce neurons, but in general, dasatinib and quercetin also enhance their neuro regeneration. Once again, you can see here that according to these two graphs, the gray bars being control, blue bars being treated fishies, showing a substantial improvement there. So yeah, let's just briefly show this paper. Now the next one is moving back again into mice, once again using dasatinib and quercetin, as well as another senolytic, fisetin, found in strawberries. And here, this study actually provides a little bit of a cautionary tale, because rather than giving the drugs to sort of middle-aged or older mice when the senescent cell burden is higher and you're expected to see more an effect from them, they actually started the treatment here with 4-month-old mice, which is roughly the equivalent of someone in their mid-20s. And they wanted to see what happened when they gave it to sort of younger mice over a longer period of time, both for male and females. And what they found out was first, there was a difference in effect depending on whether they got DNQ or Pfizer, but also whether or not they were male or female. Now, the cautionary aspect of this was the fact that for some of the, taking a look at just the graphical abstract here, for female mice given Fisetin or male mice given dasatinib and quercetin, there were very little effects here. As it says here, no effects. For the male mice given Fisetin, there seemed to be some improvements, that their metabolism improved, their cognition in terms of how long it took to find, I guess, a hole in the floor, their cage or something like that. So basically their cognition, that improved. However, for female mice, female mice on dasatinib and quercetin, their adipose tissues, their fat cells actually increased, their metabolism got worse, and their cognition got worse as well. So yeah, I mean, sometimes we think of like the longevity treatments are always going to produce benefits regardless of when they are given. But actually, sometimes it is better to wait for human trials to take place or experiments such as these to happen. So I've not taken, I'm 47 years old. I've not taken senolytics myself because I still think I'm sort of potentially too young for that. And this study seems to agree with that line of thinking. I know there's some self-experimenters out there who have started taking senolytics at a younger age, and this study sort of pours a bit of cold water upon that idea. It's probably better to wait for the forthcoming human studies before we sort of leap into senolytics. Over hopefully the remainder of this year or the next couple of years, we should get a lot more information about both dasatinib, quercetin, and Fisetin, as there are a number of studies currently underway, and we'll start getting a better idea of the benefits or detriments senolytics can have in humans as opposed to mice, because after all, humans are not mice. Surprise, surprise. Our next study, also looking at senolytics, but not in terms of senolytic results, but in discovering new senolytics. And in fact, using AI or machine learning to discover new drugs faster and more efficiently. Because of course, drug discovery is an incredibly expensive undertaking, and not only that, but it takes a large number of years from the first discovery of a molecule to actually before it arrives sort of in humans or is available for humans. It's something like 15 years or something like that. And if we can reduce that time, reduce the expense as well, then that could lead to more drugs being available to us sooner. And in this one, and so AI, obviously AI has been all the rage this year or the last year or so. People worried about it taking our jobs and basically taking over the world, basically. But provided AI doesn't take over the world, we sort of survive, or AI overlords don't allow us to survive, then AI could be very useful in discovering new drugs. And there are a number of papers have been coming out. I just actually read a new one yesterday. But here's an example of AI being used, in this case, in senolytics. Now, what made this paper a little bit different than other sort of AI drug discovery papers is that, it says here in the abstract, we report the discovery of 3 senolytics using cost-effective machine learning algorithms trained solely on published data. So other sort of AI or machine learning approaches first sort of train the AI on their own sort of created data sets. However, these guys just sort of use publicly available data to discover new potential senolytic drugs. And as they've already mentioned, they discovered 3 of them. And what are they called? They're called ginketin, periclosin, and oleandrin, which are all sort of natural drugs. And I mean, I won't go into the details of how they discovered them. Yeah, this is not my area of expertise whatsoever. But let's go look at, just briefly take a peek at some of the results. And so here we can see, we'll make this a bit bigger. So the orange, so this is a sort of a dose response curve showing on the y-axis. I always get my axes confused. Showing the senescent cell burden or the cell survival, and orange being control, purple being senescence, and let me make this actually a little bit smaller so you can see them all together. And you can see out of these 3 drugs, oleandrin seemed to have the stronger, so the quickest, the most pronounced effect. And whoa, oops. And just look at a couple other. What's this one? Yeah, here we go. It was this one. Again, just some more indication that these drugs worked. Oleandrin seemed to have the biggest reduction in senescent cell burden. Let's get the bigger bars here than the other ones. Anyway, the importance of the study is not so much this newly discovered senolytic, is more the methodology used in its discovery. Hopefully, the researchers will now test it's called oleopridine. I've lost it now. Oleandrin, that's it. Hopefully the researchers will test oleandrin in mice, see if it has a senolytic effect in them and produces some beneficial health effects. But regardless of this one singular senolytic, machine learning could, as I say, drastically reduce the cost and the time needed to develop more drugs, which, of course, considering that our time is finite, we want these drugs to be available sooner rather than later. That is an important development. Our final study involves exosomes released by induced pluripotent stem cells. Now, what are exosomes? So exosomes are chemical packets of information which cells release to communicate with each other. Now, some of them can be beneficial, some of them can be detrimental. So, for example, senescent cells, part of the bad things that they release are exosomes that cause inflammation. Now, taking a further step back, when stem cells first started really making the news, I guess 20 or so years ago, people thought that, injecting stem cells, they would produce all these sort of beneficial effects. And turned out that the beneficial effects were sort of transitory, and that the stem cells didn't survive long in the body. And when scientists looked into the reasons why they even had any beneficial effects, it turned out that it wasn't so much the stem cells themselves which produced that benefit. It was the chemicals and the molecules that they released which produced that beneficial effect. And those basically were exosomes. Now, the idea is that instead of injecting stem cells, if we could just inject the actual exosomes themselves, the beneficial ones, then we could encapsulate those beneficial effects. And also they could perhaps be more sort of something off the shelf. Now, in this study, they took exosomes from induced pluripotent stem cells. So again, remember, an induced pluripotent stem cell is a cell which has been epigenetically reprogrammed to a more youthful state. So basically a young cell. So young tissue produces more beneficial effects than old tissue. So the idea is that by getting the exosomes from these rejuvenated cells, they should hopefully produce more beneficial effects. And that is indeed what this study seems to show. Well, I wanted to highlight it because I liked the fact that it involved sort of two different things, iPSCs and exosomes. So here, again, the study was done in mice, not monkeys this time. And they basically took exosomes, then injected them in, took exosomes from these induced pluripotent stem cells, and then injected them into the mice. And they found that they had beneficial effects in the vascularization of the aorta in the heart. So vascularization means the growth of blood vessels. So here it says they promoted angiogenesis and aging aortic rings. Oops. So you can see here, okay, the difference between old and young. So the young gray bars being young. So these are sort of, I guess, control animals. Black bars being old. You can see that in young animals, they had a much better blood vessel growth, I guess. And they found that, oh, that's the young ones. Oops, yeah, here we go. So in this chart, you can see here that when they gave them to, when they injected the exosomes into the older mice, these are all old mice, it produced a lot more vascularization than in the sort of controls. Now they use a few different methods which we won't go into, but they all seem to produce a beneficial effect. In addition, so these exosomes increased the clonality and proliferation of bone marrow cells. Now, basically, what that means is that sort of improved the bone marrow. If you recall, our blood cells are produced in bone marrow. So, and a lot of other sort of important cells are produced there as well. So, if our bone marrow is well looked after, we should hopefully benefit as well. And once again, they found that at least in old animals, that the concentration of cells improved with these exosomes. So the bar on the left is sort of the control, and the bars on the right, again, using these three different modalities, showed an improvement. And finally, these exosomes supposedly inhibited aging in old mice, and they looked at sort of senescent markers once again. So two sort of markers of senescence are called P53 and P16, which we've seen a couple times already today. And in most of these instances, the senescent markers. So hold on, which graph are we looking at? So yeah, so the white bars are sort of the control in the sense. The bar on the furthest right is the old with the exosomes, and for the most part, senescent markers were reduced by these exosomes as well. So they significantly decreased P53 and P16 expression levels in organs of old mice. These are different, kidney, skin, heart, spleen, etc. And also, finally, they also increase the total antioxidant activity in the tissue of the aged mice. And once again, old controls, old plus exosomes, and although you can see that there was an increase in most of the different parts of the mouse body, they didn't return to the level seen in young mice necessarily, but anyway, the total antioxidant capacity improved in the mice in here. Yeah, I think that's all I wanted to say about this. So again, the importance here is exosomes from induced pluripotent stem cells could theoretically be banked and just be waiting for us to be used and then injected into us. So it's they could provide greater benefit than stem cells. Also, there's whereas stem cells, there's the chance of an allergic reaction, or the body could reject them, whereas exosomes do not produce the same effect, and there's less risk of side effects basically than compared to with stem cells. Anyway, that's it for this month. Thank you for joining. Thank you for watching this far. If you have any questions, please do get in touch. Love to see any comments from you guys below this video. That they are always very much appreciated. As well, please do like the video for the Google algorithm. And yes, please obviously subscribe to this channel as well. Anyway, that's all from me this month. All that remains for me to say is please, stay healthy, and see you next month. Cheers.